In this method, we are going to look at two different examples of solving a radical equation. So we will go through the steps one at a time as we solve each equation. Let's look at the first example. The square root of x plus 5 minus 7 equals 0. So we always want to start by isolating the radical expression. In this first example, the way we are going to isolate the radical expression is to add the number 7 to both sides of the equation. That way, we will have the radical sign completely isolated. So then we will have radical x plus 5 equals 7. So now our radical is isolated. Our next step is to square both sides of the equation. And the reason we're squaring both sides is because our radical sign is a square root. If it was a cubed root and the index was 3, then we would cube both sides. Okay, so now let's go ahead and square both sides of the equation. When I square the left side of the equation, my radical sign is eliminated, which means I'm just left with the binomial x plus 5. But on the right side of the equation, I square the number 7 to obtain 49. Now I'm going to solve the resulting linear equation. This case gives us a linear equation. In some cases, we will have a quadratic, but in this case, we have a linear equation, which means there's only going to be one solution, and all I have to do is subtract 5 from both sides to obtain that solution. So I get an answer of x equals 44. Now, it's very important that you go back and check your work. Not only do you want to check just to see if you made a mistake, but there could also possibly be extraneous solutions. So let's see if this example has an extraneous solution. So I'm going to replace the variable x in the original equation with the number 44. So that gives me the square root of 44 plus 5 minus 7 is supposed to equal 0. So in my radicand, 44 plus 5 gives me the square root of 49. And when I subtract 7, that is supposed to give me 0. Now, if I think about the square root of 49, that is 7. And 7 minus 7 does equal 0. Okay, let's take a look at the next equation. We have to solve the square root of 5x plus 11 minus 1 equals x. So again, I'm going to start by isolating the radical. This time I will add 1 to both sides to isolate the radical. So my radical 5x plus 11 is isolated on the left side of the equal sign, but now on the right side I get x plus 1, which is another binomial. So I'm going to go on to step 2. I'm still going to square both sides, but on the right side, I have to be very careful to put the binomial x plus 1 in parentheses before I square it. Because when you square a binomial, it's going to be the binomial times itself. So watch what happens in the next step. I can eliminate the square root sign on the left, so I get 5x plus 11, but then that equals the binomial x plus 1 times itself, because it's the binomial x plus 1 squared. So on the left, I have 5x plus 11, and then when I square the binomial x plus 1, I get x squared plus 2x plus 1. So remember to do the distributive property to multiply x plus 1 times x plus 1. Now I have a resulting quadratic equation because I see my x term has a squared power. It's a degree 2. So this is when I want to set one side of the equation equal to 0. So I'm going to solve the quadratic equation by subtracting 5x from both sides and also by subtracting 11 from both sides. So the left side is 0, and then that equals x squared minus 3x minus 10. So now I want to use the zero product property to solve this quadratic equation. So I'm going to factor the trinomial x squared minus 3x minus 10, and it becomes x minus 5 times x plus 2. So to use the zero product property, I set each binomial equal to 0, and I obtain two solutions, either x equals 5 or x equals negative 2. Now, these are possibly two solutions, because remember, I said it's really important that we check for extraneous solutions. So right now I've written down that the solutions are negative 2 and 5, but I really shouldn't have committed to that yet because I haven't checked anything yet. So we're going to go on to the next slide and we're going to check. Because both of these might not be viable solutions, which means one of them could be what we call extraneous, which means we discard it. So we want to check both of these solutions on the next slide back into the original equation. So let's start by checking negative 2. Okay, so let's go ahead and let's check the solution x equals -2. So what I'm going to do is I'm going to rewrite my original equation, but everywhere I had the x variable, I'm going to replace it with -2. So I have the square root of 5x plus 11 minus 1 is supposed to equal x. So I'm going to replace those x's with -2. So under my square root sign, 5 times -2 is -10 plus 11, and then outside I have -1, and that's supposed to equal -2. So under my square root sign, -10 plus 11 gives me the square root of 1. Minus 1 should equal -2. Well, the square root of 1 is 1, and 1 minus 1 is 0. It is not -2. So this is not a solution. So x equals -2 is not a solution. It is what we call an extraneous solution, which means the number -2 is not part of the final solution set. All right, now let's see if 5 works, because that was the other solution we found. So now we want to check the solution x equals 5. And we're going to do that the same way. We're going to replace the variable x with the number 5. So we have the radical 5 times x plus 11 minus 1 is supposed to equal x. So I'm replacing every occurrence of x with the number 5. All right, so now under my square root sign, I'm going to get 25 plus 11 and then minus 1, and that's supposed to equal 5. Well, 25 plus 11 under my square root sign is 36. So I get square root 36 minus 1 is supposed to equal 5. Whoops. And look at this. The square root of 36 is 6. 6 minus 1, yes, it does equal 5. So now I can really write the correct solution set, which only contains one number now, x equals 5. So x equals 5 is a viable solution. It works in the original equation. It makes the original equation true. And that is my only solution to this equation, just x equals 5.